All right, so in this video, we're going to go through sample question 86 from the Society of Actuaries ExamP list of sample questions. All right, so the question reads, a city has just added 100 new female recruits to its police force. The city will provide a pension to each new hire who remains with the force until retirement. In addition, if the new hire is married at the time of retirement, a second pension will be provided for her husband. I'm going to marry one of these police officers. A consulting actuary makes the following assumptions. Each new recruit has a 0.4 probability of remaining with the police force until retirement. Given that a new recruit reaches retirement with the police force, the probability that she is not married at the time of retirement is 0.25. The events of different new hires reaching retirement and the event of different new hires being married at retirement are mutually independent events. Calculate the probability that the city will provide at most 90 pensions to the 100 new hires and their husbands. Whew, that is a long problem. Okay. So let's break it down. First, I suppose it's fair to figure out what the question is actually asking. So, calculate the probability that the city will provide at most 90 pensions to the 100 new hires and their husbands. So we're looking for like the total number of pensions, I suppose. Let's say that the total number of pensions is T, right? And this is not like the value of each pension. This is just the number of pensions. We're looking for the probability that this total T is at most 90. Okay, so at most 90 means T must be less than or equal to 90. Because we're dealing with a discrete distribution, we need to account for like that correction. So T must be less than or equal to 90.5. Okay, so 90.5 is the value you're using. We're looking for this. Now, we're given like 100 new female recruits. So this kind of clues me in on using central limit theorem, right? Each recruit is independent from each other in terms of their marital status and the number of pensions and whether or not they're going to retire. And they're essentially identical to each other, right? Because they all have the same probability of all of these things. So it lets me know central limit theorem is going to be applied, right? Identical, independent, large number. So that's a normal distribution question. We need to, for T, find our expected value, variance, and standard deviation. Great. Now, before we can even find any information about the total, we need to actually extract the information about an individual officer. So let's say each female is represented by X sub I, and find those probabilities. The only probabilities we're really concerned with is the probability that this officer gets a pension, and not even gets a pension, the number of pensions that this officer hypothetically gets. So X sub I is equal to, now our options can be 0, 1, or 2, right? Maybe they retire, they leave before the proper retirement age. Maybe they are single by the time they retire, and they're married by the time they retire. And then next to it, I'm going to put the probabilities for each. So each new recruit has a 0.4 probability of remaining with the police force. So that means 0.6, 60% of all officers leave before the proper retirement age. So that means the probability of getting, of an officer having 0 pensions is 0.6. Okay, now, given that a new recruit reaches retirement, so given that we'll reach retirement, the probability that she is not married is 0.25. Now, this is a conditional probability, so we can just multiply, right? Because we're saying given that they reach retirement, it's going to be 0.04, which is the probability of reaching retirement, and the probability of being single, which is 0.25. And that's equal to 0.1, I believe. Yes. 0.1. And similarly here, that means 75% of them remain married. So that's 0.4, all the people that reach retirement. And then of these 0.4, 75%, 0.75 do not. Actually do stay married. So 0.75 times 0.4. Or not even that they stay married, that they are just married. Because sometimes people just don't do that. Okay, so now I've got the number of pensions that an officer could have, as well as the probability with receiving that number of pensions. We need the expected value and the variance for each individual officer before we can get the expected value and variance for the total by applying the central limit theorem. And because we're dealing with a discrete distribution, our expected value is going to be x sub I will be 0, right, times 0.6, 0.6, plus 1 times 0.1, plus 2 times 0.3. And that is equal to, let me just double check. That is equal to 0.7, 0.7. Now our variance of x of I should be a formula you are very familiar with, is equal to the second moment minus the first moment squared of our x of I. E of x sub I, and that's squared. Now we need to actually find our second moment. Our first moment we already have up here is 0.7. Second moment can be easily gotten. E of x sub I is equal to 0 squared times 0.6 plus 1 squared times 0.1 plus 2 squared times 0.3, 0.3. And that is equal to, so again, just 1.3. Yes, 1.3. Now applying that to our formula for variance, I'm just going to write it right under here as being 1.3 minus 0.7 squared. So that's 1.3 minus 0.49, I believe. And just to make sure I'm not doing anything dumb in my head, minus 0.7 squared, 0.81. Great. So we found the expected value and the variance for each individual. Let's apply the central limit theorem to find it for the total. And that's done pretty easily. So the expected value, or mu in this case, of the total is equal to the number of kind of items we're dealing with, which in this case is n, or 100, right? Multiplied by the expected value of the individual, which is 0.7. Okay, and that's equal to 70. And similarly for the variance of t follows the same rule, right? The variance of t is, of course, I'm going to write this as a sigma squared. That's equal to n times the variance of t. I'll just kind of write it out here because I kind of skipped that. I tend to like to, in these explanation videos, write out every single thing. Multiplied by what the actual variance was, which was 0.81, which is 81. Now, that's not the number we need. We actually need the standard deviation, which is 9. Okay, so back to what the question was originally asking for. Now that we've got our two important numbers of standard deviation and expected value, we're looking for the probability that t is less than or equal to 90.5. Okay, we're going to use the standard normal distribution to actually figure this out. So we need to standardize this. So I'm going to calculate it using z-score, and I'm going to write that formula here in red. X minus mu, our expected value, divided by our standard deviation. That is what I'm using. And this becomes t minus mu, which is 70, over 9. It must be less than or equal to 90.5 minus 70 over 9. And then this becomes the probability of z being less than or equal to, well, let's actually compute that. So that's 90.5 minus 70 divided by 9. And that's 2.277 repeating. So I'm going to round that, given that I'm going to need to use a z table, and that only goes to 2 decimal places. So this is going to be less than 2.27, or 2.28 is what I'll use. Now, I'll change this to essentially finding the phi value of 2.28, right? These two basically mean the same thing, right? This is essentially the CDF of, on a standard normal of 2.28. I'll use a normal table. Now, what I will mention is the table I'm using has negative z values. Your table will not know how to get negative z values, right? Because if this were negative 2.28, you wouldn't be able to just go here and find it. So going to our z value, we're going to 2.2, going over to 8, and that is 0.9887. So that's equal to 0.9887. And let's see which answer choice that lines up with. Ooh, very clearly lines up with answer choice E. All right, so another great example of the central limit theorem at play and how to use a normal table and the normal distribution. So what did we do? First, recognize that we have to use a central limit theorem. Why? Because we're given a list of things. We're given a lot of them, right? 100 of them. And we're told they're independent and identical. Right? Not directly, but you should be able to figure that out. So we can use central limit theorem to figure out a probability, right? By using a normal approximation. So once we knew we had to use central limit theorem, we had to figure out, okay, what are we calculating the probability of? This total. So what we needed was the expected value and the standard deviation of this total. Finding that allows us to calculate a z-score. Then we can look up the z-score on our table. That'll get you your answer. All right, if there are any questions, throw it down in the comments below. I'll answer to the best of my abilities. If this video helped you out, hit the like button, subscribe, that very much helps me out. And if you want to see more videos like this, I got a playlist, sample ExamP questions. Check it out. But other than that, thanks for watching, and I hope this helps.